One of the other uses for the Unix or Linux terminal is that we can run our programs and get output from our programs inside of the terminal. So not just using built-in tools like cd or ls or grep, but also executing our own Python code as programs at the command line. The most basic way to do this is to write your own .py file that has code in it, and then to start Python, telling it the location of that file or the name of that file that you want to run. A Python file, a .py file, is similar to having just a single cell in a Python notebook in Jupyter. And calling Python with that file's name is much like clicking the Run button when you're inside of that cell in Jupyter. We can execute our Python files as full-fledged standalone programs just by calling Python and then the name of our file. It's really just a text file. As I was discussing in some of our notes about the terminal itself, our code is just text. And so it's really just a plain text file with a special file name at the end, the .py extension. We can create them in Jupyter the same way that we create a text file, going into that main page where we see files listed and clicking New, and then choosing a Python file choosing to create a Python file and giving it that .py extension to sort of label it as Python code. And that's really all that does. If you'd like to interact with the variables and the functions inside of your Python code file, you can run an interactive Python instance, the kind that looks sort of like the command line, but you're typing Python code into it, which I've shown you earlier in the course. You do that by doing Python and then providing the option -i for an interactive version of Python, and then the name of your file. This will execute just like if you had typed every line of your Python file directly into the Python prompt there where you're able to type code. So this can be really useful if you want to test out the functions that you've written, or you have some set of functions that you know you're going to use over and over again, and you can just load them into an interactive Python run by using that -i flag or that -i option. However, if you're running it as just a regular program using Python without the -i option, then you can also write a special section, the main section, that will be outside of any of your functions. What this does is it detects that you were running your Python file as a program, not, say, importing it into something else as a library. So this is a good place to put some of your tests. This is a good place to put any interactive things that you might want to provide to a user who's running your code as a standalone program. And this stuff will not get run when you just say, like, import file name or that kind of thing. Because remember, you can import any Python file as a library, as a package inside of another program. So if your file is run from the command line using the Python and then the file name sort of command, then the code inside of this if name equals main portion will be run. If your file is run interactively or is loaded as an import, then this portion of the code will not run. We can dig a little deeper into the layout of this section of code. So it's sort of like a function. It's sort of a main chunk of your code. Many other programming languages will have you write a function named main or something similar to that. Python doesn't require you to write a main function. You can simply detect if this program is being run as the main program, not imported by something else or loaded to be used interactively. So this portion of code, to reiterate, will only execute if the file is being run at the command line as a standalone program doing something like python test.py. So here we have an example of several small Python files. We have convert.py, which we'll assume defines two functions, function 1 and function 2. It doesn't much matter to us what they do. We could just have them print or do something, return a value. It doesn't matter too much. In that file, we also have a main chunk defined there. It says if name equals main, then call function 1 and call function 2. Again, maybe we have these in there as tests so that we can see that function 1 and function 2 are working. Even after we make some changes to them, we could run convert.py and we could see that those functions still work properly. Inverse.py was written a little less cleanly, I would argue, unless you really wanted function 3 and function 4 to run every single time that someone uses inverse.py for anything. Then this might not be the best design, but it's often what a lot of beginning programmers do. So again, inverse defines function 3 and it defines function 4. We don't much care what they do. Maybe they just print out some information. Maybe they have interaction with the user that's available. So one of the big issues that you'll run into if you don't define this main portion, this test to see if it's the main program, is, say for instance, you were asking for user input inside of function 3. Well, now in test.py, where I import convert and I import inverse, when I import inverse, it's actually going to run function 3, which means that the program will pause waiting for user input, even though we were only loading inverse as a library, as a package. Often that's not the behavior you want. You wouldn't really want every time you load the math library in for your program to have to stop and to ask you whether you're using base 10 or base 2 or base 16 numerical systems, or whether you're going to use meters or feet when you import the scientific libraries or something like that. You don't want those kinds of pauses in the program. You often don't want it to actually execute the functions that are in the program. You want it to define those functions, but not to run them until you actually call them. So in test.py that's shown at the bottom here, when we import convert, it will define function 1 and define function 2, but it will not call function 1 or function 2 because those are embedded in a check to see if this is the main program. When it's imported, it's not the main program, so that whole section of code will get skipped. On the other hand, when it imports inverse, it defines function 3 and defines function 4, and then it calls function 3 and calls function 4. So that may cause output to the screen that we didn't necessarily want right now. That may cause pauses for user input or other things that we didn't necessarily mean to do. Maybe we did, and that's a perfectly fine design, but it's pretty rare that that's the case, that you actually want to call the functions when you're attempting to import them. And then just down below there, it does explicitly call to function 1 from convert. You'll notice it follows that format like we had with the random or math libraries when we imported them. We have to say convert.function1 to call that function. So they each get their own little namespace, just like the math or random packages get when we import those. It is important that these files be located in places that Python knows to look. Usually the current directory that you're executing in is the best place for when you're just writing a single program across a few different files. There are some other special directories that Python will look for code in those directories, but those are a lot more advanced to set up. So usually you want to make sure that if you're going to be importing between a few different files, put those files in the same directory with each other, unless you have advanced enough knowledge to define to Python where to look for those. So overall, we've seen that .py files are files that you can put code into and have the Python program on the system execute that code. These files are actually just plain text. They just get a special file extension to indicate that they're going to be Python code. And we can run them as main programs. We can load them interactively to work with them in an interactive Python prompt, or we can import them into other code files, into other Python files, and then use them just like a built-in package or library.